Hello, Luke. Welcome to lesson 20. So today we will be talking about volume. I know your favorite subject. So here we go. Before we dig into volume here, let's just do a very quick recap of some of the things that we've already learned. So if I have, let's say I have a line. And I wanted to measure this line, okay? I might say that I would measure it in inches, let's say, for example. And if I'm going to measure that in inches, I'd take out my ruler, I would measure it, and I'd come up with a number. Let's just say I came up with 5 inches. Obviously, this is not to scale, but let's just say I came up with 5 inches. So if we're going to measure something in, let's call this kind of a one-dimensional, maybe we'll call it, 1D, one dimensional. Okay, there's just kind of a left and a right side or length here, and that's about it. There's nothing up, there's nothing down, there's nothing deep. It's just kind of one direction. Okay, so if it's just one direction and we want to measure it, we'd pull out our ruler and we would find that in this case it's 5 inches long. All right, so that's basic. Now, if we go from there to something that's in, let's say we'll call it 2 dimensions, all right, 2D. Well, now we're actually talking about, let's say we've got a rectangle, right? So if I pull this over, okay, so now we have a rectangle. Now we have something in 2 dimensions. Not only are we going left to right, but we're also going up and down. We have a closed shape here, okay? Left and right, up and down. We're going 2 directions, or you could think of it as 2 dimensions. And now if we want to measure this, we might say, well, we're not really sure how to measure this. We don't know if we should measure this side or both sides or all sides, or how should we measure this. And as we've already learned, we would measure this by measuring area, right? And if you recall, measuring by area, all that means is we're taking squares, right? And we're just trying to fit these squares into this shape. And we're just trying to see how many squares can we get into this shape. So we might throw a 1 in there. Maybe we pull another one over, and maybe we pull another one over. And all we're doing again is just trying to keep adding these squares until we've completely filled this shape, right? So if we just, keep adding, that's one row. We could add a whole nother row here. And we find that, oh, by golly, we've got, 2 rows of 4. And so we're going to say that this has an area of 8. And again, we'll just call them inches. These are just inch squares, right? So this line, this width of the rectangle is, let's call it 2 inches, right? And thus we can fit 2 squares in there. This side we're going to call this 4 inches, and again that makes sense. We're fitting 4 squares along that side. So we have a grand total of 8 inches, but it's not just inches like it was over here in 1 dimension. We're actually talking square inches, and that makes sense because we've measured it with squares, right? We've put squares in, so our final answer is going to be in squares. So it's 8 inches squared. All right, so that's just a review of those 2. But now, what if we advance here and start talking about 3D, or 3 dimensions? All right, well, now we're getting a little bit trickier. So what might we be looking at? Well, we're looking at a shape that looks like this, right? It's well, in this case, it's kind of a box, right? So not only are we going in 2 dimensions, we're going across the page and we're going up and down the page, but we're also going back into the page. At least that's what this drawing is supposed to represent. It's kind of tricking your mind to make it look like there's depth to this shape. So you can see that we're going in 3 different directions here: across, up and down, and in, deep into the page. So how would we measure something like this? Obviously, this first dimension method doesn't really help us. We don't know which line to measure. This second one, well, we might say, well, we could find the area of one of the sides of this box, right? Kind of like what we did when we found surface area. That's exactly what we did actually in surface area. We just found the area of all the boxes and added them up. But that's only the outside wrapper that we're measuring. It's not the interior space that we would be measuring. So again, when we think of surface area, think of wrapping paper. You're wrapping the object, but you're not measuring how much space is inside the object. And that's really what we want to do here, is we want to measure the space inside the object. So how do we go about doing that? Well, first of all, let's clarify what this is. This is, in fact, volume. All right, so when we're trying to measure the space inside a 3D object, we call it the volume. All right, that's what we're looking for. And essentially, the intuition behind it is pretty straightforward. If we're trying to measure the space, well, what if we take a cube? All right, think of if you want a sugar cube or a box that's in a perfect cube. And by cube, we mean that it's a perfect square on all sides. So let's say I pull something over here. We're going to call this guy a cube. All right. And again, what that means is it's the height on this is 1 unit. Maybe in this case, we'll call it 1 inch. And then the bottom length is 1 inch. And then how deep is it? Well, that's also 1 inch. So it's going 1 inch in 3 directions, and that's forming this cube. You might think of it as an ice cube, or a sugar cube is a better example if you know what that is. So the question then becomes, how many of these sugar cubes can we fit into this big box right here? And if we can answer that, then we've answered the volume in terms of inches. All right, so if we take this cube and let's just set it in the box here. So if I kind of set this, hopefully this will all visually make sense. We're just going to kind of set that into the back corner of the box. And there's one. And now let's pull another one out here, and we'll set this one right in front of it. Hopefully this is not confusing your brain too much. So we set that one right in front. We're up to 2. Let's grab another here. Let's set that one in the back right corner. Okay, there we go. And then maybe another one. We can fit another one right in this front corner, right? So boom, there we go. We've just set 4 cubes, 4 sugar cubes in the bottom of this box. We haven't filled it yet though. So we've put 4 in, but we can still fit more. We're about halfway up, it looks like. So let's add another row. So if I take another sugar cube and I set it in there, we're going to go for that back corner there again. There we go. He's in there. And then let's grab another, and we'll set that guy in place. Okay, and we can fit yet another, and hopefully by this point you've figured out how many we're going to fit in here. We can fit one more. I know it's tricky to see, but it's in this front corner, right? So if I could put that guy right about, oh golly, here, where's my lines matching up? Something like that, right? So there we've got another row. So I know it's a little confusing now that they're all stacked in there. And before you get too dizzy, let's just clarify how many are in there. We've got 4 on the bottom and we've got 4 on the top. So we have a grand total of 8 sugar cubes, you might say, right? So what would be the area for this this box here? Or next, excuse me, I'm sorry, what would be the volume for this box here? Well, it would fit 8 inches, but now we got to be careful because we're not talking squares. We're not talking 8-inch squares like these ones. We're actually talking something 3-dimensional. We fit 8 3-dimensional cubes inside this box. So it's 8 inches to the 3rd power, which we read as cubed. All right. And that, again, makes sense because what did we do? We fit in cubes into here. So 8 inches to the third, we would read that as 8 inches cubed. That's, how many cubes we could fit into this larger box. Again, this one was squares because we were fitting squares in. They're not cubes, so this is 8 inches squared. This one is 8 inches cubed. All right, so hopefully you see the difference there, because that's very important in your homework. If they ask for the length of something, you just give it in units. If they ask for the area, maybe we'll write that here. If they ask for the area, then you give it in squared units. All right, and that includes surface area. And then over here, if they're asking for volume, well, then you need to give it in cubes. So it's inches cubed. All right. So that's kind of the intuition on what's going on behind all of this. But now we have to come up with kind of a method by which we can solve more complicated shapes, the volumes of more complicated shapes. So let's just kind of think about how that worked out for us here. And if we think about it, we can see, let me just grab my pointer here. You can see that the sides, all right, let's just talk about the sides of this big box for a second. If I pull this out, right, and set it over here, okay, so we can see that the sides of this unit are the height of 2 of these boxes, right? And if these boxes were 1 inch, remember we said they were 1 inch going in every direction, well, then it would make sense that this is, 1 inch here, another inch here. So the side of this large box must be 2 inches tall, right? Does that make sense? Because we've got this side here, which would be 1 inch, this side here, which would be 1 inch, right? Because they're cubes, and that's how many fit in, exactly 2 high. So there would be 2 inches. So this side is 2 inches tall. All right. Now on the bottom, kind of the same thing. We've got 2 boxes side by side here in the bottom. And so that would indicate that this is 1 inch, the bottom of that box, and this is 1 inch, the bottom of that box. So the bottom of this shape is also 2 inches. So the height is 2 inches, the bottom is 2 inches, and really, if we look over here, we've got 2 boxes side by side here too. So we can say this is going to be the inch, this is going to be 1 inch. So again, this is also 2 inches. So for this particular box, it's actually a cube, right? It's just a larger cube. It's a cube with 2-inch sides. All right, so it's 2 inches in every direction. So let's talk again about a method here that we can use. So what I might do is just see if I can't, I think that grabbed what I wanted to grab. Boom, boom, there we go. All right, so we're gonna kind of clean that up again. Let's take this cube one more time, and let's look at it and just ask ourselves, how would we find the area without actually stacking all these boxes in here? And to do that, we need to recognize that if we take the bottom of this box, right, we cut it down the middle, and we cut it this way. That's kind of the grid that those 4 boxes are going to sit on. Hopefully you're able to see this. That is the bottom of this cube. So if that's the bottom of this cube, then this is, let's get rid of this here. Let's go to here. This is, remember we said this is 2 inches, and this is 2 inches, and this is 2 inches. Well, we can find the area of that bottom box, right? So if I just take a different color here and just emphasize what we're trying to do, we're trying to find the area of this bottom of the cube. Okay, there's the bottom. All right, so we're trying to find the area of that. So if we find the area, we just take length times width. In this case, because it's a cube, we take side times side. So 2 times 2 is 4. So the area of this bottom of the box is going to be 2 times 2, and I'll put here area, is equal to 4 inches squared, right? Because remember, area is squared. So once we've found the area of the base is 4 inches, basically what we've done is we've decided how many cubes can fit in that floor or on that floor, right? There'd be 4 of them. 4 cubes can fit on there. So the next thing is to figure out, well, how many layers of cubes are we going to have? Well, because it's 2 inches, we know that that first layer is going to be a cubic inch. So that first layer is going to go up an inch. The second layer is going to go up a second inch. And so we're going to have 2 layers, which makes sense because it is 2 inches tall. And we're using inch cubes. So we can fit 2 layers, right? So if I wanted to find how many blocks were in all, I would say, well, there's 4 layers on the bottom, and there's 2 layers that are exactly the same. So you'd have 2 groups of 4. And of course, we all know that 2 groups of 4 is just another way of saying 2 times 4, right? Which is the 8. And then we'd have to remember that this is the full volume, so it's inches cubed, not inches squared. All right? So the method that we're going to use to solve these problems is to simply find the area of the base and then multiply that by the height. All right, so maybe I'll write that out here. We'll say volume. Volume, how do we do it? What's the formula? It's the area, and then underneath I'll just put base, okay? So this is the area of the base times the height. All right, that'll kind of be our formula. The area of the base, which means the bottom of the shape. All right, now the only time this would not work, and I want to make sure you understand this, is if we had something that was maybe, let's see if I can draw something here. I'll have to draw it freehand. Let's say it's something like, oh golly, I don't know if I can actually draw this, but let's say it's like a pyramid. So if we've got, whoa, not that. Let me go to this. So if we've got something that looks like, we've got well, no, why don't we do something like this maybe? Okay, so we've got this. And now if you can imagine this kind of comes up to a cube. Okay, kind of think of, maybe if I draw it like here too, maybe, I don't know. Okay, kind of think of like a tent, okay? And I don't know if you can see this drawing at all. Probably kind of making a mess of it. But we're kind of drawing a tent, okay? And if you think of that, would we be able to use this method here, this formula for finding this area? You might say, well, we could find the area of this base, right? Find how many, what's the area of this base, how many cubes could fit down there. But do you see how the layers, the number of cubes that would fit in each layer is going to decrease as we go up this tent, this pyramid. Each layer is going to take fewer cubes because we're narrowing to a point here. So we can't just find the area of the base and multiply it by whatever this height is, okay? Because the layers are going to change as we go up. So bottom line, this formula here, it'll only work if we're talking about a right solid. Now, hopefully you recall what a right solid means. A right solid is where we have a figure that has a base and the sides go straight up from that base. These are all 90-degree corners in here. They're all going straight up. Okay, straight up. They're not leaning one way or the other. They're going straight up. And that's a right solid. Okay, so the first thing we really need to look at is, do we have a right solid? Do we have a side in which we could place that side as the base, and then everything else is straight up from that side? And if the answer to that is yes, well, then we can definitely use this formula to find the area, the volume of that shape. Okay, so let's try a couple of problems here and see how you do. So we're looking at this particular problem. This one should be pretty straightforward. It's essentially what we just did. So take a minute and try to navigate through this and determine what the volume is for this shape. All right, so let's take a look at what we've got here. Let's go to our formula, the formula for the volume of a right solid, which again, we can picture, or at least hopefully see that that's pretty clear that this right solid is going straight up. If we chose, you know, kind of this place right here as the base, right? It's going straight up from that base. Okay, so it's a right solid. We can use our formula. Volume equals the area of the base times the height. All right, so the first step is to find the area. And what do we have for a base here? Well, we have a square, or not a square, a rectangle for the base with a length of 3 and a width of 2. Well, area of the base in this case, the formula is going to be simply length times width, which is going to be the 3 times the 2, which is going to be 6, and they're in inches, so it's inches squared. So that's the area of the base right here. All right, so now we just need to find the height. So maybe we'll go to a different color here. We'll say we need to find the height. So the height is what? Well, the height is 6 inches, right? It's from here up to here. That's our 6 inches. So the height is equal to 6, in which case we can plug that into our formula. The volume equals the area of the base, which we said was 6 inches squared. So we put our 6, and actually our height is also 6 in this particular case. So we'll multiply that by our height, and that, of course, is going to give us 36 inches. But now watch out, it's cubed, raised to the 3rd power. All right, so that would be our volume for this shape. Pretty straightforward. All right, now hopefully you can see this picture. I tried to kind of shade some of the sides, give you a little perspective on it. You'll have to pardon my drawing here, but hopefully you can see that it has kind of a triangular base that goes up into a triangular top. Okay, so the first thing to recognize here again is, and maybe I don't know if this would help, but if I kind of maybe draw in like an invisible what's going on here at the base, right? So that's kind of the base underneath. So the thing we need to recognize is that the base is the same as the top. The sides are straight up from the base. And if that's the case, we can use our formula. All right. So recognizing that, what I've done here is just drawn out that base. So I just took that base, and that's, you know, unfortunately my drawing isn't perfect here. That almost makes it look like a right triangle. It really shouldn't be. It's the same shape as this one here. My drawing just isn't perfect. So anyway, so this is I'm going to tell you that this is the shape of the base right here. It's also the shape of the top. So if this is the shape of the base, let's find the volume. So if we're going to find the volume equals the area of the base times the height. So the first step, let's find the area of the base. So let's find this guy. So the area of the base, well, the base in this case is a triangle. So we need to think of the area formula for a triangle, which of course is 1/2 times base times height. So what's our base? It's a 2. So we have 1/2 times a 2 times our height, which in this case is given to us. It's 6. All right, so what's 1/2 times 2 times 6? Well, 1/2 times 2 would be 1. 1 times 6 is 6. So it's 6 centimeters squared, right? All right, so that's the area of the base. Now we have to find the height. Well, I didn't give you the height in this one, so I suppose I'd better do that. We'll make up a number. Let's say the height is 5. All right, 5 centimeters. Okay, so with that information, let's continue the problem, and we'll find the height next. So the height is 5. That's pretty straightforward. So we'll just say h is equal to 5. Okay, so now we can complete our volume formula here and say that the volume is equal to the area of the base, which we already said was 6. And then we have to multiply that by our height, which we said was 5, which then is going to give us a grand total of 30 centimeters, in this case, cubed. That would be the volume for this shape. That's how many cubes that have sides that are all 1 centimeter long we could fit into this rather triangular box. All right, let's move on. So here's maybe a little bit more of an interesting one. So they just keep getting more complicated. So again, this picture shows the shape of the base and the top of this figure. All right, so let me give you some dimensions here. Let's say this is 2. This is, so we'll go with a 4. This is a, well, it doesn't really look like a 6. Let's make it, well, I guess we'll make it a 3, I guess, and see how that works out for us. So this is the base, and then we'll say that the height is, 10, just for the fun of it. All right. So again, what are we going to do? We recognize that this is a right solid. The sides go straight up. Okay. So we can then use our formula. And what is our formula? Volume equals area of the base times the height. Okay, so area of the base, well, here's where we have to actually do a little work to figure this one out. We've got kind of a triangle mixed with a rectangle here. So this is where all the things that you've learned before with area have to come into play. You have to have that toolbox of methods to solve for these area problems. So we'll draw a dotted line here. All right, and we recognize that we're dealing with two things here. We're dealing with a rectangle, right? This side here, and then we're also dealing with a triangle, this side here. Okay, so let's take your pick. Let's pick the rectangle first. That's a nice easy one. So to solve for the rectangle, we know that the area is length times width, which in this case our length will be 3 and our width will be 2. So we have 3 times 2, which is going to be 6. And let's say the units are inches, inches squared. So there is our area of the rectangle. Now we need to look at the area of the triangle. So if we go to area of the triangle, we know that the area formula is going to be 1/2 times base times height. And we know that, well, what do we know here? Let's take a peek. This is where we need to do a little work. If we recognize that this side has a length of 3 and this is a rectangle, well, then wouldn't it make sense to say that this side, this dotted line, also has a length of 3? All right, so now we just figured out the height of our rectangle. It's 3. We need to figure out what the base is. Well, we know that up here, this length is 2. So that must mean that this length is 2, because again, these are right angles. So this length is 2 from this corner all the way to the dotted line. And we also know that this whole line at the bottom is a 4. So from the corner to the dotted line is 2, and the whole line is 4. Well, doesn't that mean that the leftover part here has to also be a 2? So that these two sections of the line add up to 4, which would be the total length of the line, right? Do you see that? So knowing that, that's how we can find the length of the base. So now we have 1/2 times base times height. So we have, in fact, 1/2 the base is going to be the 2. So 1/2 times 2, and then times our height, which is 3. 1/2 times 2 is going to be 1. 1 times 3 is 3. So we end up with 3 inches squared for the triangle. Now we can figure out the area of the whole shape. So the area of the whole shape is just the sum of these two. So the area in this case will be 6 plus the 3, which is the 9. So that would be the area, and we'll call it the area of the base here, so we don't get that confused with these other two areas. So area of the base is 6 plus 3 equals 9. That is the area here. Now we just need to multiply that by our height. So our height, we said, was 10. So we can move on to the, well, let's pick a different color here. Let's go green. So the volume is going to equal the area of the base, which we said was 9, times the height, which we have written over here. They gave that to us, is 10. So the volume is 90, in this case, they're inches, let's say, inches cubed. All right? Excellent. Hopefully that makes sense to you. And then let's do one last one here. So here we have another shape. It's another right solid. These are right angles in here. And we want to know what is the volume for this shape. So again, our volume formula is area of the base. Whoops, I suppose I could write that out. Area of the base times the height. Okay, so area of the base, that's always going to be the hardest part for these problems, and that's why it's so important that we are very good at finding areas, because that's key to finding volumes. All right, so the area of this base, well, in this case we have a circle for a base, right? So we need to find the area of the circle. So what's the formula for the area, and maybe I'll put underneath this, of a circle, just to clarify what we're doing. The area of the circle is going to be pi r squared, right? So now we can start plugging things into this, and we'll say that this is going to equal r, which is what? That's given to us. It's a 2. So it's going to be pi times 2 squared, which of course is equal to 2 squared is 4 pi. And I'm just going to leave it like that for right now. So that's the area of the circle. Now, or you might call this the area of the base, right? Because that's what the base is. So now we need to find the height, and that's been given to us. They say that's 10. So to find the entire volume, we take the area of the base, which was 4 pi, times that by our height, which is 10. And that should be pretty easy. 4 times 10 is 40. And then you take the 40 times it by the pi, which would be the 3.14, which we'll just do that real quickly here. 125.6. So it's 125.6, and we didn't get units, so we're going to write units. Units, if I can spell units, cubed. And that would be our final volume for this can, so to speak. All right. Good. So I hope that makes sense, Luke. It's pretty straightforward. It's simply knowing the area of the base and then multiplying it by the height to find out how many cubic units can fit into the right shape, the right solid. All right. In a lot of these problems, they might even just outright tell you what the area of that base is. So read the problem carefully and understand what they've given you and what you need to figure out. All right. And that's all we have for today. So good luck, and head over to the homework section or the seat work section where you can start working on that. And we will see you tomorrow.